Hi everyone, we are going to use synthetic division for finding limits in a very specific situation. So we have this problem here and we're looking at finding the limit as x approaches -2. Plan A for limits is always just plug in the number and see what you get. If I plug in the -2, I will get the 2 times -2 cubed plus the 7 times -2 squared plus the -2 minus the 10 divided by -2 plus 2. And if we do all the math on that, I'll let you work that out, but if you'll trust me for a moment, we get 0 over 0. If we have 0 over 0, that's when we go like, oh, dang, we're a little stuck. This is one of our indeterminate forms, as in you cannot determine it. So basically, we don't know what the graph is doing right now. Yes, I know I could graph it, and I actually will do that in a moment. But the way to deal with this is using something called synthetic division, or sometimes gets called synthetic substitution. The two words are interchangeable. So the way this works, we'll take our coefficients of that top and write them down. So 2, 7, 1, -10. We also take basically the thing that limit, we're plugging -2 in. So here's how this guy works. And okay, it's not why it works, it's just the mechanics of it. If you really want to know the how and the why, I'm sure you could research it. This is a magic trick. I hate magic tricks to be honest, but in this case, we're going to use a magic trick. It happens very infrequently in this class. I usually tell you why we do things. In this case, not so much. Okay, so we have our -2, we have our coefficients. I'm skipping a line because I need to be able to write on that. And then underneath here, so the thing I do, this first number, I drop it straight down. I have a 2. And then I take my -2 and this 2 at the bottom, and I'm going to multiply them together and get -4. So the -2 times the 2, -4. And then I just add straight down and get a 3. I'm going to repeat my multiplication. 2 times -2 times the 3, I get -6. And then I'm going to add -5. I'm going to multiply again. So -2 times -5 is +10. And then I add and I get a 0. Okay, this is super artificial, this particular problem. Having that 0 is super important. If something besides a 0 showed up in this situation only, something went funny. So what we have now is this 2, the -3, and the 2, the 3, and the -5. What this means, or what we have now, is basically I've just divided this cubic by this x plus 2. So really, what I've essentially done is I've factored that numerator, which I know it doesn't look like I've done it, but I have. And again, if you really want to know all the whys and wherefores behind all this, feel free to Google it. I'm not going there. It's a really limited problem that we do this. So the 2, 3, and -5 are actually the 2x squared plus 3x minus 5. And then I have a x plus 2. So basically, those three numbers are the three numbers we had in our synthetic division are the coefficients of a quadratic. If we're dividing a cubic by an x, essentially, we get a quadratic in return. It's just a really weird way of factoring. And I have my denominator. I'm keeping my limit notation because we haven't taken a limit yet. Now that we have this guy right here, you're probably looking at that going, oh, we can cancel those the x plus 2's out. Fantastic, let's do that. So now I still have my limit notation. And I have 2x squared plus 3x minus 5. And this is kind of weird. So remember that with limits, we're saying x approaches that -2. It's not x equals the -2, but we're saying what happens as we get as close as we feel like getting. But we end up just kind of cheating and plugging that -2 in. It's a little bit weird. Remember, with limits, you want to think less, not more. That's kind of our key thing. But now that we're at this point, We can plug in our -2 because that's always your plan A for doing limits. And so we can just plug that guy in. So we have 2 times -2 squared plus the 3 times -2 minus the 5. And if you chunk all that through and do the math, you get a -3. So the limit as x approaches -2 for this original guy is -3. So now let's prove that, or kind of, it's not proving it, it's just showing it on our calculator. So in my y equals, I have put in that original function. Notice that my numerator is in parentheses, my denominator is in parentheses. If you do not put the parentheses there, things will be way wrong. And when I graph this, you can see that there's a gap. Now, technically speaking, this gap is infinitesimally small. It's only a gap at -2 itself. As soon as I'm just off of the -2, there's function there. If I hit trace and type -2 in, you can see there's nothing there. But look, if I look at, say, -2.001, so I'm really close to -2, but not quite there, I'm at -2.9949. You can probably go, hey, yeah, that's good. That's -3. Or looking at the other side of it, -1.999. I'm still at really close to the -3. Just to illustrate that this 2x squared plus 3x minus 5 is basically the same, I'm going to type that into my y2 to show it. So basically, these two things that we have are identical for every single number on the planet except for -2. And it seems weird that we can use these to compare when we're looking at -2, but remember, limits are saying get close to -2, not actually at -2. We're squinting, remember, that's what limits are about. It was kind of the squint. But now look at what happens. It's going to draw it and completely cover it. And you can see that it totally lines up. And when I hit trace on that negative and go to -2, y1, there's nothing there. But if I arrow down y2, it's at -3, which corresponds to the -3 we found. So that's using synthetic division or synthetic substitution for finding a limit in a very specific situation. And in all honesty, it doesn't show up a ton. The main point of this video is to show you that synthetic division. If you want more examples, just search synthetic division and you'll find a lot.